All right, let's get into something where we can pass the test case. So let's see what we need um, to pass one of these. So test get. Um, so this is calling get team info. Okay, so that's something I should be able to do. So get team info for the Chicago Cubs in 1998. So I can do that one real quick because I should have that, right? So get team info. So this is going to return team data dot get for the team code um, and dot get for the year. So hopefully this is an easy win right here on the get. I built this a while ago. I forgot about this one. So this gives us the data structure that I already populated and just be able to return one of them. So let's see if I can get that. Oh, so that did not work. What happened? No pointer exception. The value of something is null. So let's see what test line. Oh, okay. Made up teams should have returned null. So it did. It seems like it worked through all of these. That I actually did load up my Chicago Cubs 1988 properly, but I forgot the fact that I also need to deal with some made up team in 2022 doesn't actually have any data right there. Okay, well that's annoying because my stuff's working, but it's true for my function here, my method. I need this to be sensible. So so well, this actually gets me back. I'm just going to copy it here. Um, this right here, and this is the one. Oops, excuse me. Um, this is the one that's coming back null. That's the reason why I'm getting null pointer exception. Um, so, well, I called this all teams before, so I'll do that again. And so I'm going to go get all teams first. All right. So if all teams is equal to null, then I'm going to return null. All teams, that teams makes more sense than team. All teams, otherwise, I'm going to say all teams dot get the year. So that should fix that thing that I broke right there. So let's see what happens. Yes, excellent. I passed my first test. So I know, at least for the 1998 Cubs, I am loading the proper data for that. And so I passed one of my tests. Um, so we can pick any of the rest of them here that we want to pass. Let's see if there's one of them that seems easier. It's test average. Um, average cost per win. It's saying it should be 751,000, but we have 205,000. So um, hmm, I'm not entirely sure why that one's off because we're adding it in, and this might be so we have 1/3. So maybe we're adding in more wins than we're supposed to. Um, so I'm going to put a pin in that one because that might actually be a problem in the test case because of some of the things I noticed about the data, or maybe I messed up the data file in some way. So I'm going to put a pin in that one. We'll come back to that one in a second. Um, attendance. Let's see what this one is. Oh, okay. So this is the rest of these I need to do some more processing on. So let's do some of that more processing. So let me get some of this out of the way. Clean up my workspace because it's making extra stuff in the way. And I'm going to get rid of this outline because I'm done with that for now. Um, so let's talk about how do I get to answer one of these questions. Um, cost per win per year. All right. So let's figure out one of these, and then we'll figure out how to do it more efficiently later on. All right. So we want to get a list of team info for a given year. Well, we have all of our team data, and we can get the team info for a given year, but we can start simply by saying we want to return this. And just define what this is, all teams for year, is equal to a new array list. And we're going to build that up. We're going to build that up for every team for that given year. So what we need to get is team info for a particular year. And so I'm going to create this variable, set it aside for a second. And I need to do that by going through all of my team data. So for, well, we have that map of integer team data, which is all teams in team data dot values. So what did I do right here? I'm sorry, not team info, not team data, team info, right? So I'm looking at the values of team data, which is all of the maps of the teams for the different team codes. So I have all of that data. Oops, let me go back to here. I have all that data. I'm going to go through each one, and I only need the team info for a given year. So I'm going to move this right here. And this is going to be equal to all teams.get for the year specified. So just to be safe, if the team is null, I'm going to continue to the next one. Because perhaps the team didn't exist in a given year. They weren't created yet, or they are no longer. They're defunct. That's so. It doesn't mean I'm broken. It just means I skipped that team if I didn't get one back for that year. Just a little safety valve right there. I should probably put this around it to be clear, but since I'm doing a one-liner, this works fine. All right. So for that, all the teams for the year, well, I can basically say all teams for year dot add team. I don't want to add any null ones, but I can just add them all in, and then I can return all teams for the year. So wait, that doesn't give me rankings, but it does give me the cost per win. So let's just see what happens. Let's just go ahead and toss that in right there. So this is the one I'm working on. I forget which test case I was working on. There you go. Test costs per rankings, test costs. So that's the one I was working on. So let's see what the error is. The first team did not match expected. So it expected the first team to be the 1998 Washington Nationals, but we gave the Texas Rangers, I think. Okay, well, that's because I didn't rank my teams at this point. I just got all the teams for that year. And we want to do the cost per win rankings here. So we don't want to just simply add them, and we want to add them in order. So we need to do a little bit of sorting here, which is something maybe you should be familiar with, right? So two options. We can either create our list of teams and then sort them, or we can insert them in a sorted order. So this is a nice little harken back to the previous class. And if you want to take this on your own just to test yourself, feel free to just pause this and jump into it. It doesn't matter how you do this, but I'm going to keep working on it from here. And I don't remember how I did it last time, so we might have a little adventure here. So I think what I'm going to do is I'm going to put it in inserted order here. So what I'm going to do is I'm going to start by calculating the cost per win. And it's going to be a double, it's an easy thing to start with because it's going to be the team.get salary divided by team.get win. All right. And so now and so, I'm going to get insert location. It's going to start at 0. For int I is equal to 0, I is less than all teams for year dot size, I plus plus, and we want the cost per win rankings. I don't remember if we're supposed to do high to low or low to high. So let's assume it's high to low because we can always switch that later on. So if um, the cost per win is greater than the team I'm currently looking for. We'll say team info compare team is equal to all teams for year dot get I. So we're going to compare our team we're inserting to the teams that are already out there one at a time. And so compare team dot get team salary divided by compare team dot get team got get wins. If we're greater than that, then our insert location is going to be equal to I. Uh, and so actually, let's start the insert location at um, the last one instead. So if we're the smallest, well, then we'll assume that we're going to be the smallest right there. And so this is going to be the all teams for year dot size. All right. So if the size is 0, then the insert location is 0. We skip this array, and then we will just simply do a all teams for the year dot add. And there's two types of adds. I can either add at the end or add at the index. We'll say the insert location, comma, team. All right, so I might have constructed this in my head properly. I might not have. I've done enough of the sorting that makes sense. But let me reiterate my algorithm to see if it makes sense to you as well. So our insert location is going to start at the last location. So we're going to assume it's the smallest. And then we're going to go through this one at a time. And if we're bigger than the one, then our insert location becomes that one. And oh, by the way, since we know it's the biggest one, we can break out of the loop at that point. We can stop looping here. So we assume it's going to be the last one, and then we stop early if we find one that's bigger than. Otherwise, we keep going to the next one, and then we add it at that location. So let's see if I solve my problem here. Test cost. The first team did not match expected. Um, the Washington Nationals, and we returned the Baltimore Orioles. Uh, oh, because I think we did it backwards, and I know this from the data that the Baltimore tends to spend a lot of money for that. So I think what we want is not the cost per win. We don't want the highest cost per win. I think we want the lowest cost per win. So we want the exact opposite. So that theoretically should be easy to do. So we're going to assume it's the last one, and then if it's less than, then it's going to go at that location. Okay, so let's see if that works. Yes, we got it. All right, so that works out nicely because now we know for any given year, we know which team spent the least amount for that year. Yeah, so that's the cost per win rankings. And so if you have questions on it, let me know. It makes sense to me, but I do feel like it kind of came together quickly. And so if you're not sure about exactly what we did in the sorting, let me know. You're not going to have to do a ton of sorting in this class, but it is a useful little insertion sort, which is much more efficient than a traditional insertion sort because I have to add them to the list. I'm adding them at the list of the most advantageous location at this point. Depending on the order that comes in, I'm looping through the list n times. But you know, if they're bigger, then it shortcuts it there. So it's not bad. It's not maybe the most efficient ever. Maybe it would be better sorting it afterwards, which I certainly could do. But here's the catch: I'm not inserting the values. I'm inserting objects, and so I'd have to do a different sort of sort, or I'd have to add some extra Java stuff. So this one works pretty well. All right, so I'm going to leave this one here, and we'll jump onto another one in the next video.